Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is prefix suffix string, and it is a medium level problem. So the problem statement says that we have been given two lists of string S1 and S2, and we have to count the number of strings in S2, which is either a suffix or prefix of at least one string of S1. So let me just show you, like, with the help of a sample test case. So each string in S2, so in the S2 list, we have a string cat, we have a string dog, and we have a string rat, right? So for this to contribute in my answer, for the first string to contribute in my answer, it should be either a prefix or a suffix of substring in S1, right? So for the first string in S2, it is exactly similar to the first string in S1, so you can either call it prefix or suffix, like both of them are equal, right? Now if you consider the second string in S2, so like from the first string cat, it has contributed 1 to my answer. Now for the second string S2, in S2, which is dog, you see that the second string in S1 has dog as a suffix, right? So it has dog at the last, so this will also contribute 1 to my answer. Now for the third string in S2, the rat, it is not nowhere present in the string, the list S1, so it will not contribute to my answer, and its contribution will be 0. So the total answer will be 2. So like this is how the test cases are working, and this is our problem statement, that then we have to count the number of strings in S2 such that it is a prefix or suffix of at least one string in S1, right? Now, talking about the constraints, each string in S1 and S2 has a maximum size of 25, and the total length of S1, that means the combined length of all the strings in S1 is around 10 raised to the power 3 in both S1 and S2. So if it is up to 10 raised to the power 3, we can do an n square loop in either one of those strings. Since the constraints are very small, there are actually a lot of ways to solve this problem, and like some of those ways also include calculating all the prefixes and the suffixes in the string S1 and storing it in a data structure like a map or a set, and then while traversing through S2, you can just directly check whether this particular string or any string in S2 is present in that particular data structure or not, right? So there are actually a lot of ways to solve this problem, but we are going to discuss one very interesting way of solving this problem, that is using try. So the only reason I am discussing this particular approach is because I wanted to show you the application of try, right? Again, with the help of try, there are actually a few ways. So I tried two of the ways with which you can solve this problem. So I'll discuss both of them one by one. So the first way is to, like, for example, if you have a string like this cat and then you have a string lion, right? So the basic concept of try is you have a root node, and also I wanted to mention one more thing, that try, try in general can have more complex implementations as well. The implementation that we are going to discuss here is the like most simplest one, and it is like not even used anywhere. It's just that our idea is from the concept of the try, but our implementation will be far different from what we generally implement in a try. So even if you don't know try, you will be able to understand this particular solution and you will be able to code it on your own, because we are just going to include the most important things from try. So we are going to use our knowledge of try, we are not actually going to implement a fully fledged try, right? So like the basic concept of try is for every like what do you say, index. So for example, this is index -1 where the string is empty, right? So when the string is empty, you have 26 spaces, right? Among these 26 spaces, what do we have to do is, so the first space corresponds to the letter A, the second space corresponds to the letter B, third C, and then D and E, and so on, right? This list goes on. Now if the next character is A, now I'll this is one particular node, right? This is one particular node. Now if the next character is A, it will point to another node, which will have a similar data structure, which will having A, B, C and D up to 26 characters, right? So for example, let's say this is A, this is B, this is C. So if the next character is C, this particular pointer will point to the next node, again having the same similar data structure, right? So what do we do is, at each step, what are we doing? If the first character is A, we just mark a pointer to the next node, and this node will denote that we have traversed A till now. Now if the next character is C, we go to this particular node, and then we know that we have traversed AC till now, right? So this way we will be able to get all the prefixes. Like let me give you more examples with the help of these test cases. So for example, here it is written cat and dog. So let us consider this case where we have cat and dog. Right, so this is one string, there are no spaces. I just wrote it that way. So for example, this is the first node. Let's say we have C here, it will point to something. This is the second node. We have A here, it will again point to something. We have the third node. We have T here, so T will point to something. Here it is T, it will point to something. We have the fourth node. We have A here, again it will point to something. In the next node, we have N here, again pointing to some value. D. So let me just write it now in a smaller way. This is also D, this is O, and this is G. Right. So like this now at the end, like it seemed like a linked list, but what happens is whenever you have some other character. So for example, you had CAD in the starting, right? So CA here is common. Now if you have D, D will point to somewhere else, right? So it is not exactly like a linked list, it is similar to a linked list, right? So what happens is whenever you are searching for a prefix, let's say cat, right? So what you will do is you will go to the first position, you will see, right, the next character can be C is present. Then you go here, you see the next character is A, the A is present. Then you go to the next element, and the next element you see the T is also present, the T is a valid character. Then you move forward. For example, you wanted to search for cop. So you come here and you see that the first character is C has a valid pointer. You go to the next area. Now you see that O does not have a valid pointer. That means there is no string in my dictionary or in my initial list S1 which is starting with CO, right? So I cannot move forward from here, and hence COP will not have any valid prefix. Now we have discussed about prefixes. What about the suffixes? How do we handle that particular case? So like one way of implementing that was what you could have done is you would have taken CAT as a string, and then you would have taken AT as a string, and then finally you would have taken T as a string. Right, this solution would have worked, and you will see that whenever all the prefixes of cat would be covered. So this is one prefix, this is the second prefix, and this is the third prefix. Now if you search for any of those prefixes, all of them will be found. So this was one way of doing it, but for some unknown reason, when I coded it, this was not working on like Geeks for Geeks. It was working when I was executing the same sample test case on the custom input. It was working absolutely fine. It was working fine on my local machine, but when submitting, this approach was not working. So we're going to discuss a different approach from this one. What we have to do is, for example, we have got a string, let's say this cat and dog only, right? Cat and dog. So we know that DOG is a suffix of this particular whole string. So we created a try for this whole string. Now what we'll do is we'll reverse the string. So this is God, DNA and TAC. We will reverse the string. We will also build a try for this particular string as well, right? When we build a try for this particular string, while searching, we searched for dog from the string S2. We also reverse it. We will also search for God, right? So you will see now God will become a prefix of this particular string. So the thing is, what you have to do is, while building the try, you store the original string, you also store the reverse string. Also, while checking whether the current string is a prefix in the given try or not, we check the first initial string, and we also check the reverse string, right? So reverse string will basically be depicting the suffix of the original string, right? So this way you can check both the forward and the reverse, or the prefix and the suffixes. So the key idea is to maintain a node in which each node will have a vector or an array consisting of 26 pointers, and each pointer will correspond to a specific character. So you will see that at this particular position I have encountered C, at this particular position I have encountered CA, at this particular position I have encountered CAT, And in this particular question, I have encountered CATA and then CATAN and so on, right? This is how this particular try concept works, and we are just going to use this part of try. There are actually a lot more things we have to consider while implementing a try, but we are just going to use the very most important stuff. So I'll repeat, the basic idea is to use a try, and checking the prefix is easier in try. For finding the suffix, what we'll do is we'll just reverse the every string in the initial list S1, and we'll also build a try for the reverse string. And while traversing through the string S2, we will check for the initial string and we will also check for its reverse string. So this is our whole concept. So let us have a look at the code now. So the code, I've tried to keep it as simple as possible. So what I've done is, you see that my try node has only one element, right? This is the only thing that I have. It is a vector of data type, which is a pointer of toward another try node, and the size is 36, and it is consisting of null pointer, right? So this is how I initialize all the values. Now what I do is, I'll just initialize my root as a new node, right? So I have a root now. So this is my build function. I'll be discussing it in a while, and this is my checker function. I'll also be discussing it in a while. So first of all, let us see what we do with the strings. So I traverse through the list S1. I call the build function for the current string, and I reverse the current string. I also called a build function for the reverse string, right? Now I initialize my answer with 0, and I traverse through the list S2. What I do is, I maintain a boolean variable. I just check whether it is possible for S to exist. I reverse the S, and again I check whether it is possible for S to exist, for the reverse string to exist. If in either of the ways, okay, it is true, so that is why I am taking OR. If either one of them is true, I'll just add it to my answer, right? So this would be my approach. Now talking about the functions build and check. So what I do using the build function is, I just initialize my current node as the root node. Now I traverse through the whole string S, and I set the next character as S of I, right? So I'm checking the next node. While I'm building, I'll check whether the next node is a null pointer or not. So I can easily check whether the next node is a null pointer or not. That means, let me just explain you this part also. So when am I at the root node? For example, this is my initial root node, and let's say the first character we have encountered is C, right? So C does not have any pointer. So what I do is, I assign a new node to C and set this value and set the pointer of this particular node here, right? So this is what I'm going to do. Now you see, whenever the current whatever the next of current character is null pointer, I just create a new node and store it in the next node, and I just assign the value of next node into that particular pointer. Otherwise, I'll update the next node as current next, right? So if the next node already exists, I'll just update the value of next node. That means there was already some string S which had a prefix similar to my current string, right? Then I update the next node, and finally I update the current node with the next node. So this is what is going on here. Now talking about the checker function. So this is very simple. It is even easier than the build function. I just initialize my current node as the root node. I initialize my index as 0, and I'm traversing through the whole string S. Now I set my next character as S of index, and I check whether the current character for the current node, the next character is a null pointer or not, right? If the next character is a null pointer, that means I cannot traverse my current string from S2, right? I cannot traverse the remaining characters from S2 of the string from S2. So I can just break out of this loop. Otherwise, if I can traverse it, I assign the current node as like the next pointer that it is pointing to, and I increment the value of index. At the end, after this while loop is executed, I just check whether this index is equal to s dot size or not. If it is equal, I just return true, otherwise it will return false. And after all of this has been executed, I'm just going to return my answer. So this would be the solution of today's problem of the day: prefix, suffix, string. So I believe that this would be the most optimized solution, and as the time complexity suggests, and it should be maximum of length of S1 and S2. So for each of those strings in S1, we are calling it twice, so it is actually twice of maximum amount length of S1 and S2. So I believe this is okay, because 2 is a constant factor and it will be approximately this particular value only, right? So I believe this was it for today's video. I hope you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to subscribe to this channel. I have also shared it before that a lot of users who watch these videos have not subscribed yet. So please do consider subscribing, and till the next video drops, keep coding, stay safe, bye bye.